Hi everyone, welcome to this video about the Dependency Inversion Principle, one of the solid principles in object-oriented programming. In this video, we will discuss what the Dependency Inversion Principle is, why it's important, and how you can apply it in your code. What is the Dependency Inversion Principle? The Dependency Inversion Principle is the D in solid, which stands for Dependency Inversion Principle. It states that high-level modules should not depend on low-level modules. Instead, both should depend on abstractions. Abstractions should not depend on details. Details should depend on abstractions. Why is the Dependency Inversion Principle important? The Dependency Inversion Principle is important because it promotes loose coupling between modules, which makes it easier to change, test, and maintain code. When we follow this principle, we can change the implementation details of a module without affecting the other modules that depend on it. It also makes it easier to test our code because we can replace dependencies with mock objects. Let's take a look at an example to understand how the Dependency Inversion Principle works in practice. Suppose we have a class called Notification Service that sends notifications to users. The class has a method called sendNotification that sends an email notification to the user. Here's the code for the Notification Service class. This code violates the Dependency Inversion Principle because the Notification Service class depends on the implementation details of sending email notifications. If we want to change the way we send notifications, we would have to modify the Notification Service class, which violates the open/closed principle. To solve this problem, we can use the Dependency Inversion Principle. We can define an interface called iNotificationSender that abstracts the concept of sending notifications. Then, we can modify the Notification Service class to depend on the iNotificationSender interface instead of the implementation details of sending email notifications. Now, the Notification Service class depends on the iNotificationSender interface instead of the implementation details of sending email notifications. We can create a separate class that implements the iNotificationSender interface for sending email notifications. We can then create an instance of the Email Notification Sender class and pass it to the Notification Service class. This way, we can change the implementation details of sending notifications without affecting the Notification Service class. We can create a new class that implements the iNotificationSender interface for sending SMS notifications, for example, and pass it to the Notification Service class without modifying the Notification Service class. In conclusion, the Dependency Inversion Principle is a fundamental principle in object-oriented programming that promotes loose coupling between modules. By depending on abstractions instead of implementation details, we can make our code more flexible, testable, and maintainable. In the example we've seen, we used the Dependency Inversion Principle to refactor a Notification Service class that depended on the implementation details of sending email notifications, and we abstracted the concept of sending notifications using an iNotificationSender interface. This allowed us to change the implementation details of sending notifications without modifying the Notification Service class. By applying the Dependency Inversion Principle in our code, we can build more robust and scalable applications.